Thanks everybody for rejoining us. I'm delighted to be able to introduce our next speaker. Our next speaker is Percy Liang. Percy is joining us remotely from California. He couldn't make it physically here today, but he's having to get up very early in order to be able to make this slot, and we're very grateful that he's making the time. Percy's group, of course, at Stanford was the group that coined the term foundation model, and it's the best term I've seen so far to describe this new class of machine learning technologies. So Percy, we're extremely grateful that you can join us and very much looking forward to some insights from you. So I'm going to magically wave my hand and hope that Percy appears. Fantastic. Percy, thank you for joining us.
All right. Can everyone hear me?
We can hear you perfectly.
I can hear myself, so.
So over to you. Thank you.
All right. Thanks for the introduction, and I'm really happy to be here, at least virtually. So this is one of my favorite topics to talk about foundation models. Today, I'm going to present us on holistic evaluation of language models, a new benchmarking effort that we've been working on over the last year to really shed some light into the capabilities and risks of these language models, but eventually more generally foundation models. So at Stanford, I started the Center for Research on Foundation Models 2 years ago after GPT-3 came out, and it was clear that this technology was going to take off, become extremely valuable and interesting and potentially dangerous in some ways. And over the last even few months, it seems that this was a really a wise move. So the Center for Research on Foundation Models is housed under Stanford's human-centered AI, which seeks to put a human-centered angle on the development and study of AI. Okay, so this is a large project that involved multiple people. So at CRFM, we tend. Okay. Oh, okay, sure. Hold on. Let me share my screen. I don't know what happened here. Oops. Okay, apologies for the hiccup. I think we should be ready to go here. I think nothing was missed in the first two slides. So this was a large project by a whole host of people. So as CRFM, we focus on these ambitious, large projects that involve many participants. And in this project, we are also grateful to Google, Microsoft, OpenAI, Cohere, AI21 Labs, Anthropic, and Together for providing credits and compute. And I should mention that the two stars of this project are Rishi Mamasamy on the left and Tony Lee, who with me helped drive this project. So the starting point is this observation that benchmarks orient AI. So benchmarks are things that encode explicitly or implicitly the values of a community, what kind of things we care about. And historically, they've been extremely influential in governing where AI goes. For example, ImageNet, Squad, Superglue from NLP and Vision. Once they're released, they sort of define a North Star, at least for a few years, as the case may be. And you see these leaderboards where people try various things to improve accuracy, usually on these benchmarks. And in some ways, these have fueled the deep learning revolution, and also foundation models, I think, wouldn't have really been possible without the variety of benchmarks to show their utility. So benchmarks are very important. So, but language models are sort of a different thing altogether. So what is a language model? To put it simply, it's something that takes text in and produces text. The input text is called a prompt, and the output text is called a completion. For example, you can have Stanford was founded in, feed it into a language model such as GPT-3, and you might get a completion like a date. So in some ways, it's a very simple and elegant interface. And that simplicity is what I think makes it really powerful. So despite its simplicity, the thing that's important to remember about language models is that it has immense capability and risk surface. So this is a screenshot of OpenAI's website where they advertise all the different things that one can do with the language model. And you can see that this goes far beyond traditional NLP tasks like name entity recognition or question answering. You have, really kind of long tail events like movie to emoji or summarize for a second grader. These are things that the academic community or no one was explicitly working on, but just is another capability of the many, many capabilities of language models. And this is going to be what makes evaluation hard. Because for question answering or image classification, you can scope the task, you can gather a data set and try to define what models on that data set can do. And even there, that's really hard to make sure that your data set doesn't have artifacts. But in the language model case, it's just much, much more difficult. So this is a challenge we seek out to tackle. There are two goals that you want in a benchmark for language models. One is to improve the transparency. So currently, we have a suspicion that language models are very powerful, but we don't really maybe know what it can and can't do. You can go on Twitter and you can see a lot of posts on either really good or really bad examples. But what is sort of a more level-headed objective take on the language modeling capabilities? Given this transparency, if you have it, then it enables the community, language model developers, to form norms around what constitutes progress. Again, this kind of North Star that people are going towards. And furthermore, it grounds the conversation not just among technologists and researchers, but along other folks who are eagerly looking at the language model and foundation model space, for example, policymakers. And I think this is an important point because there's been a lot of talk about what should we do to govern or regulate AI. But I think without having a formal, rigorous grounding of what is going on with these models, we end up maybe getting a little bit unhinged. So the second point I want to make is that we want to design this benchmark to ultimately guide the socially beneficial development of these language models. From that perspective, we want the scenarios that we're testing to be ecologically valid so that they occur more in the real world. We want to go beyond just accuracy, which has dominated benchmarking thus far, and look at bias, robustness, calibration, efficiency, and so on. And we ideally like to embrace more human-in-loop evaluation. So we don't do this explicitly in HELM, but I'll mention another project at the end of the talk. So there are three features of HELM that I want to point out. The first is broad coverage and recognition of incompleteness. So remember, one of the challenges, perhaps the principal challenge of evaluating language models, is the huge and vast capability and risk surface, right? So how do you even begin to conceptualize what are the things you should be testing? And the previous benchmarks, which are already very thorough, things like the original GPT-3 benchmark or Big Bench or Luther's AI harness, they tend to be more bottom-up. They define benchmarks as a set of tasks in the traditional NLP sense and just put them together in a nice format so that it's easy to evaluate all of them. But how do you know you've covered the space well enough? So in HELM, what we decided to do is try to taxonomize or articulate the space a bit more. So we factorize the space into task, what the domain of that task is, who generated the text, when it was generated, and what language it is. And you could see, for example, that question answering on Wikipedia generated by questions generated by web users in 2018, that corresponds to the natural questions data set, which we have. Whereas maybe information retrieval and news, where you're looking at Black speakers pre-internet in Swahili is something that we don't have. So this is sort of a subtle point, but the benchmark actually sort of reifies and includes things that are missing. And there's always going to be things missing. And this, I think, making that explicit, I think, allows us to, extend the benchmark and recognize some of its current limitations. We'd also do the same thing with on the metrics that we're evaluating, which is something maybe I'll get to a little bit later. Okay, so the first point is recognition of incompleteness. The second feature of HELM is multi-metric measurement. So typically in benchmarking, you have scenarios such as these, and usually each scenario comes with one principal metric, usually accuracy, but sometimes it'll measure things like bias or robustness. And I think one a problem with this more siloed approach is that when you're looking at question answering, you don't just care about accuracy, you care about robustness, you care about fairness and all these things. And so by measuring bias on a completely different scenario, which may be less ecologically valid, maybe you don't really get a sense of how biased your language model is under real conditions. So what HELM does is you can think about it as a matrix where rows are the scenarios of interest and the columns are the metrics. And what we try to do is basically fill out this matrix. So for every scenario, we're committed to measuring not just accuracy, but calibration, robustness, fairness, bias, toxicity, and efficiency. So the third point is one of standardization. So a lot of benchmarking has happened. Every language modeling paper that has come out has done some evaluation. But when we look at across all the models, so now the columns are models instead of metrics. It's a little bit probably too small to see, but it doesn't really matter what the individual models are. We see that the coverage is actually very sparse when you look at even the most common scenarios. Some models are evaluated on some of them, but for example, some of the models aren't even evaluated on any of them. And this makes it hard to compare the different models because they're not evaluated on the same thing. So in HELM, we rectify this by filling in the matrix. For every scenario, we're committed to evaluating each of the models, at least on a subset of core scenarios. Okay, so that was the 3 points in recognition of incompleteness, multi-metric measurement, and standardization. So these are the key features. So now let me step into more of the details of how the benchmark was, what's in this benchmark. So let's talk about scenario. So the scenario is meant to capture a particular use case or situation where you might want to apply a language model. And as mentioned before, the scenarios are organized according to a taxonomy, which breaks down into the task, which would be question answering, summarization, and so on, and basically domain and language in which the task is meant to be targeting. And this tracking, explicit tracking, is helpful because you might have a summarization data set, but it only covers some subset of the domains, and maybe you're not measuring the fact that summarization on dialogues doesn't work nearly as well as summarization on news, for example. So just saying this model does summarization isn't really enough. You need to know what domains it can actually summarize. Okay, so I'm going to walk through some of the scenarios that we have. So I should mention that most of these scenarios that we have are actually previous papers that have been so a lot of the hard work actually comes from the people who made these data sets. We're merely collating them. In the paper, we do create some new scenarios, but that's maybe secondary, I would say. So the first scenario is question answering. So this is a massive multitask language understanding data set from Hendricks et al. And here the input is a question, and the set of references, which are in some sense, the possible answers, are this. So it's multiple choice question answering. And one of the references here is marked as correct. Here's another one, MS Markle, where the goal is to do information retrieval. So given a passage and a query, you're trying to answer whether the passage answers the query or not. There's summarization, the popular CNN Daily Mail. So input document, and you're trying to generate a summary. Civil comments. Each instance consists of some sort of text, and you're trying to classify whether it's toxic or not. IMDb's, this is a classic sentiment analysis data set. Given a review of a movie, predict whether it's positive or negative sentiment. Raft is a collection of a bunch of different text classification data sets, which are maybe less of the usual type. So this is categorizing types of banking customer service, which might show up in some real world applications. There's 42 scenarios in total. We're looking at, I just showed you 6 of them, just to give you a flavor of what's inside the benchmark. Okay, so now let me talk about metrics. So first we start with accuracy. So this is the typical accuracy where for multiple choice, it's very clear. You just see if you got the answer right or not. For summarization, we look at automatic metrics, but we realize that these are actually not very good because the data set is sort of maybe less than ideal. So we also do human evaluation on the data sets that have long generative output. So second metric is looking at calibration. This basically measures whether a model knows what it doesn't know, which is a really important thing. Otherwise, because these models just make things up often. So the way we measure this is we look at models that output a probability. So it's required that the model output a probability to measure calibration. It could be anywhere between 0 and 1. And for each time the model, let's say, outputs probability 0.2, we measure did the model actually get it right or wrong. Okay, so for every value of probability, we have both the sort of a correctness and also the probability. So now we want to see if the probability output by the model on average is similar to the accuracy that it's given. So if the model is outputting like, I'm 70% sure, then it should be the case that 70% of the time the model is correct. Otherwise, the probability doesn't really mean anything. So you look at basically the average here and the average here and take the difference. That's the expected calibration error. And lower is better here. So the third metric we look at is robustness. So this looks at inputs to the model, and we apply perturbations, typos, synonyms, and so on. And we look at whether the model output changes, or more generally, whether the model gets the perturbed input correct. And so this is a general framework that we implemented for applying perturbations to inputs, and this allows us to measure robustness on any scenario. Using the same perturbation framework, we are getting at notions of fairness. I want to caveat that fairness is a more complicated, as is robustness. These are complicated topics. What we have here is a sort of a simple operationalization, which tries to do, is a first step, I would say. There's much more you can do by extending the perturbations or looking at other things. But here, the idea is to take pronouns and swap out the gender and see if the model changes the prediction accordingly. And this is testing sort of invariance. Okay. There's another type of bias, which is looking at model generations and seeing if there's higher co-occurrence between, for example, male terms such as his and he, and a particular word such as occupation like mathematician, versus female terms like her and daughter. So if co-occurrence of mathematician and male occurs, let's say, more than mathematician of female, then there is bias. And I don't think it's important to mention that these metrics aren't meant to be, there's no kind of normative reference point where it has to be 50-50. This is simply a measure, and certainly one shouldn't try to drive this number to 50-50 because there could be other externalities that could arise from that. But this is just a measure, I think, providing information about what the model behavior is. So toxicity is another metric we looked at where given a model's generation, we run the Perspective API, which is a classifier that does toxicity classification and sees the fraction of the time toxic output appears. And here again, toxicity is a very nuanced and subtle and controversial notion, and this we're just operationalizing in a fairly simple way. So the final metric is efficiency. So most of the models we have access to is just via API access. So one clear thing you can do is to feed the prompt into a black box API and wait for how long it takes to generate the output. So this is the raw runtime, and you can denoise it in a little bit. But one of the problems with this is that it totally depends on what kind of architecture you have. If you have A100s versus, if you have 16 A100s versus one 3090, that's going to be very different and not really a property of the actual underlying model. So we also compute an idealized runtime, which is standardizing the hardware and computing this metric. This requires knowledge of the architecture, which we don't have for all the measures, all the models. Okay, so just to wrap up this part, we have this matrix of scenarios, which are use cases where we want to apply the language model, and metrics, which are the things we might care about when the language model is applied. And for both, we try to be as systematic as possible in covering the space. And of course, there's many things more you could do, but we're trying to at least in the last year, at least have some sort of representative coverage of all the major properties that we care about. Okay, this is more fuller version of what that looks like. Okay, so let's talk now a little bit about the models that we're evaluating. So we evaluated 30 different models from 12 different organizations. Basically, every major language model that we could get a hold of, we were able to evaluate. This table shows who created these models. Most of them are text, 2 of them are code. Number of parameters, some of the parameter counts are sort of speculative but not really known because OpenAI doesn't really share the parameter counts. The access column shows that some of these models are either open, which means that the model weights are available and you can just inspect the model, look at it. Some of them are limited, which means that we have API access, or the public in general has API access. And some of them are closed, which means that this is not available for the public in general, but through a grant program or things like that, we were able to get access from Anthropic and Microsoft. Okay, so I should mention that one thing that distinguishes HELM from many benchmarks is that not so much the declaration of, not just the declaration of here are the things we want to measure, but actively going out and measuring them on the artifacts that we think matter in the world. Okay, so let me talk a little bit about adaptation. So this is a sort of a technical, I mean, it's an important technical detail, but so I should mention it. So remember that a scenario, for example, question answering, you have a question and then you have possible answers. And adaptation is a process of converting what task you care about into a language modeling prompt, sort of programmatically. Okay. So there are multiple ways to do adaptation, aka prompt engineering. we took the stance that you can do a lot of things here, but we wanted to do something basic and importantly do the same sort of adaptation for all the models. So there's, for example, two ways you can do question answering adaptation. The first way is you say the following are questions, and then you give 5 examples of questions from the training set. This is doing in-context learning. And then you give a test input, and then you ask the model to, you label each of the references as A, B, C, or D, and then you output the label. So the nice thing about this approach is that it directly, you just make one query to the language model, and then you get back the answer. You decode only one token, so that's cheap. The alternative is to take advantage that you have a language model that's meant to complete sentences. So you can, for every candidate answer, you can measure the probability that the answer follows the question. And you take the answer with the highest probability appropriately normalized. So this requires 4 queries in this case to the language model. So it's more expensive, but sometimes it yields better results. In general, we went with a kind of the cheaper, simpler alternative. But there are cases where if the task looks more like language modeling, you want to do the latter. Okay, so let's look at some results. So one of the things that's really interesting about measuring a lot of different metrics is that you can do these meta-analyses where you plot accuracy versus each of the other 6 metrics: calibration, robustness, fairness, bias, toxicity, and efficiency. And each point here is a particular scenario and a particular model. And you can see basically how the metrics correlate. So for robustness and fairness, there is strong correlation, I would say. So meaning that the models that do better on accuracy are on the whole more robust. It's not completely clean, so sometimes you get reasonable accuracy, but you actually worse in robustness. But it's it's okay. We see that calibration is almost completely uncorrelated, meaning that how accurate you are and how confident you are about your answer are really sort of orthogonal almost. And this is striking because a lot of the more accurate models are very confident in their wrong answer. And this is exposing this problem. You can see that bias is also not so correlated. Toxicity is sort of different because toxicity sort of only appears in this narrative QA, which is question answering books. And efficiency is also not really correlated. And this is because some of the models which are really high performing are instruction tuned, which means that there's additional training beyond just pre-training a language model, which allows you to get good accuracy with much lower resources. Okay, so this is another plot that looks at the ranking of the different models under the different metrics. So what we have here on the x-axis is the win rate, which is how often a particular model beats other models across the scenarios. And we see that here the top models are the OpenAI models and the big Microsoft TNOG model and Anthropic. They're sort of at the top, and then you have OPT for accuracy. For calibration, it's interesting. It's actually completely changed, where the OpenAI model is actually way down here. Robustness is pretty correlated with accuracy. Same with fairness, and you see that the others are sort of in different configurations. So notice, again, it's not to say that necessarily higher is better, and we should optimize for bias, lowering bias on this particular metric. But it is informative, I think, that it's not the notion of best model according to accuracy is not necessarily best according to other metrics, which is again the value of having this multi-metric framework. This plot just shows that the accuracy over time on various scenarios goes up with additional model releases, as you might expect, with some jumps. One thing I want to highlight is that all of these results are available through a website that we built, and I think this is actually one of the most exciting parts of the framework is that you can go in and you can explore. So here's the website. It talks to you about what HELM is, and at the bottom, it lists all the models that we evaluated, plus a few other ones which are in gray. So the ones that are in gray means that, again, this philosophy of explicitly marking incompleteness are models that we would like to evaluate, but haven't yet. So this is sort of a to-do list that you can see. So here's ChatGPT. We'll do that soon, hopefully. Same with the scenarios. They're grouped by question answering, information retrieval, summarization, and so on. And there's different data sets on here. There's these aspirational settings, which are things that we would like to evaluate, but we haven't done that quite yet. And then all the metrics that we looked at. So I should say that the 7 metrics are really metric classes. Within each metric, there's actually a whole host of different things. So this is a very kind of rich data set. So let's dive in a little bit. So you can click on a scenario, and this is MMLU. You can see the table, which shows all the different models and the different metrics. So if we go down to, and I should also mention that this website is sort of being updated. So this has actually already have new models that weren't in the paper. So if you want to look at the HELM results, I would go to the website because that's going to lead the paper. So if we go down to a particular subject area, you can see different models. If you click on one of these models, let's say, I don't know, DaVinci 002. So this is one of the OpenAI models. We see that all the scenarios, all the instances within that scenario. So here is an instance, here's the input, here's the references, which one's correct. And for each of these instances, we actually do 3 random trials. So this is something that's also atypical in this in this space, where we randomize over the different choice of in-context examples, and we are able to track the variance. So you could see that the metrics on a per instance level, so it got this one right, but this one wrong. And we see that there's a kind of original instance, and there's with a perturbation. So this one has extra spaces and maybe lowercasing and stuff like that. And if you click into one of these predictions, you can actually see the entire prompt that was used to query the model. So ideally, if you copy and paste this into the OpenAI API, you should get whatever answer was predicted. So the website, I think, is really cool because it gives you both the aggregate statistics, but then you can drill down and all the way down to the prompts. Because often you see these papers with a lot of numbers going up and plots that go up and to the right, but it sort of makes you wonder what is actually underneath them. Are the metrics and benchmarks meaningful? And we're trying to basically expose that to whoever wants to take a deeper dive. And in doing so, we actually realized that some of the benchmarks are maybe not measuring what we thought they were measuring. So this is just a good lesson. Okay, so that's all I wanted to talk about on the website. And okay. So all the code is available on, on GitHub at this URL. One of the things that we're hoping is that this is more than just a concrete benchmark that we built. It is a framework for doing any sort of language model evaluation, or even using a language model. We've standardized the interfaces to all these models. So I hope that this will spur research where if you wanted to make conclusions about a language model, you can use HELM and evaluate on maybe dozens of language models as opposed to only the OpenAI API, for example, because I think that that would allow you to draw more robust conclusions. And and excuse me, I would hope that this also is open source project that will welcome community contributions. Okay, so what's next? As I mentioned before, HELM is not a static entity. We put out the paper, but we're far from done because this field moves incredibly quickly. Since HELM came out, there's been many models that have already been added to the to-do list, open models, as well as Cohere and AI 21 actually updated their models, so we ran another round of evaluations on them. And of course, now with OpenAI's ChatGPT, Bing Chat, and all these other things, I think it's exciting to update the webpage, every few weeks just to keep up with the state of the art. And some of these models are still closed, and we're also trying to see if we can get access to benchmark them, so we have a more complete picture of all the foundation models in the ecosystem. We're also looking at different domains like biomedicine and law, different tasks, especially generative tasks, since that's a new capability that ChatGPT and has really kind of exposed. I mean, some of these capabilities were already there, but I think they've been more popularized, let's say. And then doing more AI safety evaluations, because I think that's a really important thing to get right. We're also looking at other modalities. So we're actually working on evaluating image generation right now because we're interested in foundation models more broadly, not just language models. I alluded to before, there's an ongoing project on measuring interactability. And the key idea here is that thus far, we've talked about benchmarking as you have an input and the system or the model tries to solve the task autonomously. But in the real world, if you look at how people are actually using these models, it's with human in the loop. You generate some ideas and then you revise and then you generate some more. And it's really kind of an interesting form of interaction. And I think the language models open up a whole way of interacting with AI in a way that is not captured currently by any of the existing language modeling benchmarks. So this is a paper that we just put out that looks at 5 different tasks and does human in the loop studies. For example, whether a model, if a human using a bot can answer questions better. And I won't have time to go into this, but I'll feel free to ask me questions. So let me conclude. So benchmarks orient AI. Benchmarks play a very crucial role in not only driving progress, but also asking the question, what is progress and what values do we care about? And I hope that with a multi-metric approach, we can start to shine a spotlight onto other metrics besides accuracy, things like robustness or calibration, And if we can highlight them more, then hopefully progress will increase along those other dimensions. I think I've shown you how we've dealt with the problem that language models has this immense capability of risk surface. We try to taxonomize, we try to admit when we don't have something. And this is really just a work in progress. Even with the current language models, we haven't measured everything, but we have a framework and a process for doing so. And as new models come out, that surface area is just going to grow. And I think we have to work even faster to keep up. The HELM, the H stands for holistic. We talked about how this encompasses many axes, holistic along the scenarios, models, and metrics. And this you can think about this as a 3 tensor that's growing very, very quickly. And how should you use HELM? I think HELM, we've designed it to be not just an academic benchmark, but with 3 audiences in mind, I would say. One is to researchers and developers who want to know how good their model is. This is more of the classic setting. I hope that this will also provide transparency to actually users of the model. So someone who's trying to use ChatGPT or another model, they can actually look at HELM for an objective opinion on where this model is useful versus not useful. And finally, auditing. I think these foundation models are becoming incredibly important in our society. They're going to on their path to being deployed everywhere. And I think we have really limited tools to assess that impact and govern whether certain releases or deployments are responsible or not. And I think tools like HELM can help steer us in that direction by again providing resources for auditors and policymakers to look at so that they can have a grounded sense of what's happening in this space. And finally, this is meant to be a community effort. We put out an initial version. There's so much to do, and I really welcome everyone to take a look and send me thoughts on how you would want to extend HELM. And with that, thanks everyone for your attention and happy to take questions.
Thanks, Percy. So we have plenty of time for questions, and I'm sure there are plenty of questions. Let me take chair's privilege, if I may, Percy, and just ask, so the term foundation models that you and your group coined, which is the term that we've adopted at the Turing Institute to refer to this class of systems. Could you say a little bit about how that idea evolved, how it came about, and what the thinking was in you and your group in the origin of that?
Yeah, that's a great question. Oh, there's some feedback here. So 2 years ago, this was during the depths of the pandemic. GPT-3 had just come out, and it was clear to us that there was something new kind of emerging on the scene, and that it was not going to be just another kind of technical change, but something that was going to have sweeping social consequences as well. So at HAI, Human-Centered AI, we started talking about this, and I went around, remember, in talking with people from all over campus, and everyone was excited, but there was always a lot of uncertainty about what was this thing. It was at that time GPT-3 was the term that we were talking about, and language models, of course, but at that time I think language models maybe didn't have the same, or even large language models didn't really have the same weight that it has now. But we felt that through these discussions that the term language model wasn't capturing everything about what was happening. Neither was self-supervised models or pre-training. All of these were technical terms which were accurate, and there's a place in which one should use the word language models, as we do here, and there's a place where you should use self-supervised learning, but a term was needed to capture the sort of the gravity of the paradigm shift that we were emerging. So given that we need a new term, the question was what it should be, and this was reflecting back a very drawn out process where there was a lot of actually internal discussion at CRFM, very vibrant discussion. Many terms were tossed around, base models, poly models, infra models. And I think one thing that came out of this was, one thing that we wanted to capture was that fact that these models were incomplete. They needed to be adapted to downstream tasks, and the word foundation, captures that. So you have a foundation. It's not the whole house. It's just the foundation of the house. But it's also a very important piece, because if you get the foundation wrong, then your house falls apart. So that's why we chose the word foundation model. And we've actually, in the original foundation models report, we have a section that talks about more about the kind of the logic, but I'll maybe just leave it at that for now.
Okay, thank you. Over to our first question.
There's a general problem with Goodhart's law, and once HELM becomes more popular, there's going to be incentives to try to do well on HELM. I think that we will constantly add new scenarios. We are also doing things like working with providers to make sure that there's no train test contamination. Hopefully, by having multiple metrics and not singling a single number makes it harder to maybe game and optimize, but we'll see what happens with that. So generally, I think to avoid gaming, I think we need to think carefully about it in general. And so far as safety is concerned, safety is a very broad topic. The way that I would maybe conceptualize it is that there are a few aspects of it. I think a core aspect, if you think about safety, is just measuring the capabilities. So things like being able to persuade other humans or take on multi-step plans. These are things that are in themselves not maybe bad. Actually, there are many positive use cases for this, but they signal an increase in capabilities, which sort of increases the variance of possible outcomes. And then there's more maybe explicit harms metrics, which we sort of started getting into. I didn't talk about this explicitly, but we have a more targeted evaluation on disinformation and whether these models can be used to generate disinformation. There's one aspect of safety is, under adversarial conditions, can you do things like get the model to do something bad or give you information that it's not supposed to? And we're looking at that, although the adversarial setting definitely makes it more challenging for a static benchmark. So this is, so maybe those are some thoughts on this. It's sort of still kind of work in progress, but hopefully we'll have a new version at least for some of these metrics, and we'll go on from there. What I've actually shown as part of HELM is, in some sense, the evaluations that we did. Maybe there's multiple. I'll maybe try to conceptualize it this way. There's a space of all possible scenarios and metrics, which is infinite. We don't have access to that. Then there are things that you can think of and write down. And for example, let me try to go to the website. There are things that you can write down. Oops, that's the wrong. And so, for example, data to text generation, fact verification. These are things we haven't, implemented, but we can write down. These are aspirational. Then there are things that are, are implemented in the Helm framework. So there's actually a few other ones which are implemented in the Helm framework which we didn't run. The way we think about it is that there's a sort of a quote unquote priority system where things get implemented. And I hope that the community will add additional scenarios to Helm, and you can run these scenarios. And then, of course, it's the main bottleneck at some level is it becomes compute, right? Once you can't run everything. Helm was actually trying to run as much as we can, and we still didn't run everything because, the compute costs were actually, even just for evaluation, were getting quite steep. But then I guess the way that we would decide whether something is maybe more prioritized is a combination of how salient this is in real world deployments, versus, as well as how different it is and complementary it is to other things. So you can think about maybe like a sort of a diversity, like kind of in recommender systems. If you have diversity, you want to capture the kind of the modes, but have maybe kind of prototype typical examples to try to cover the space. Another thought is, I think it would be really interesting if the choice of scenarios could be more community driven. We haven't figured out exact way to implement this, but I think it would be cool if people contributed to Helm, and then we had some sort of voting scheme for people to declare, hey, I really want to see story generation, for example, and then using the votes to help prioritize what to run next. A great question.
Okay, we don't have too much time. I'm trying to take the hands in the order in which I see them, so I'm doing my best. And so the first is over here.
There are quite a few different metrics. So we talked about how you can look at the accuracy versus other metrics and see if they're correlated. Calibration, I think, is one of the ones that stood out as being maybe not obviously correlated. There are also sort of interesting things, like, for example, we evaluated 003, the text DaVinci 003, which is OpenAI's latest models, and actually it performed worse than text DaVinci 002 in a bunch of settings. And we dug a little bit deeper, and we found that text DaVinci 003 for sentiment classification, where the output should be positive or negative, was actually outputting neutral for some reason, even though it was prompted to only output positive and negative. So maybe just shows that the space is so vast that progress is not necessarily monotonic. I mean, on average, things will go up, but I think by looking across and breaking things down, you could see how accuracy is changing, because there are certain settings where upgrading to the latest model might, for your use case, be not a wise thing to do, which wouldn't be something that you would notice without a thorough benchmark.
Okay, so we're just only going to be able to take two more questions. We've had a question come in online which has got lots of upvotes. So this question is, how collaborative has big tech been? How can people best contribute to research or open source who aren't working for big tech?
Okay, so maybe there's two questions there. So how cooperative has big tech been? Maybe I'll scope it to the HELM benchmark since we've worked with them. I would say that it's medium in the sense that many of the models that we like to evaluate are not available yet, and so we're trying to work on that. But certainly, they've in general have API access and for researchers to use. So sort of and credit. So it's better than nothing. But I think we can do a lot more. I think one of the things that is not necessary. So part of it is maybe not wanting to disclose secrets, but also the other thing I noticed is that it's just kind of a matter of priorities, because as we see today, even the big tech companies which have tons of resources are trying to go very quickly to try to improve capabilities and get the products out and so on. And there's just not very much bandwidth, I think, for supporting more open academic research. I think it's what we can do as a community is to keep on pushing for greater transparency and access, because I do think that having access to these models is important. And I think a dangerous thing is for the academic community to be completely detached from what's happening, which we're seeing a little bit, like the amount of resources you need to train GPT 3.5 or GPT 4 is just insane compared to what you would do in a typical NeurIPS or ACL paper if you're not from, and a lot of those models aren't even published. So I think there's this growing gap that I think we should work constantly to reduce.
Okay, great. And our very last question down here. Sorry, folks, we just timed out.
Certainly, there's not a model that strictly dominates all the other models along all axes. I think some of the stronger models are, close in the sense that TextDaVinci 03 is going to be much, much better than like a 6 billion model along almost every kind of capability metric. But I think so in terms of like gross trends, I think you can talk about average progress being meaningful. But if you look at how people often use these benchmarks to sort of hill climb and say, oh, okay, I want to improve the model, and I'm comparing two models which are very close, then I think it's going to be hard to really make sure that you have a clean signal based on the HELM score, because things are going to be different. Sometimes you improve one thing but hurt another thing, and so there are trade-offs that you have to make. And I think that's sort of good in some sense, because maybe the criteria should be that you shouldn't hurt any individual metric too much as you're improving your model. So you can adopt a more worst case kind of attitude towards evaluation rather than an average case.
Okay, great. Percy, we thank you so much for doing that. We are now going to move on to the panel. If you need to grab a coffee or something, you've got 2 minutes to do that while we assemble ourselves on the panel, and then we'll move on to the panel questions. So can I ask the panelists to come up and join me on the stage?
They told me to sit on this side. Particular seating? It depends where your microphone is. You're all in the centre. I've got to be this side of centre.
Okay.
Where do you want to be?
Wherever you want to be. Yeah, go for it. No. There's no hierarchy here.
I'm going to go straight to the sparkling water though, because otherwise I'll have a coffee fit and be unprepared.
That was fun.
Okay, so while our panelists are collecting their thoughts, let's just run through the questions that, that we generated. So the first question is really, is there good reason to believe the hype? So these models have, as we've talked earlier, they've gone viral. They've got, ChatGPT has hundreds of millions of users and so on. Do they deserve the hype they've received? And if so, why? And what are the capabilities that most surprised and impressed you when you came across these technologies? Did you expect to see systems with the capabilities of ChatGPT by now? Are we where you thought we would be? And researchers like Mirella and Phil, who've been in, for example, in natural language processing, Maria, who've been in natural language processing for a long time, it's going to be fascinating to get their insights on whether we are where they thought we would be. Do we think progress is going to flatline or continue? So, neural networks famously in the 1980s, the parallel distributed processing revolution showed an awful lot of promise, but within a decade or so it started to flatline, not because the core techniques were wrong, gradient descent was there, the core techniques would be familiar to machine learning researchers today, but because the data and compute required to make it work at scale simply wasn't available. Are we going to see a similar thing? Will we run out of data? Will adding an order of magnitude more compute power to each iteration simply not become feasible? What potential applications excite you the most? So there are a million possible use cases for this, but what is the one that you think is going to be the killer application? What is the one that's going to be really transformative? We've heard a lot today about concerns around large language models, so I talked about them, and others have talked about them. Hallucination being very high priority. But what are the ones that bother you the most? And it may well be not something that's been mentioned today. And finally, are foundation models the right foundation for AI? Is this the way machine learning is just part of a much bigger field? Are these platforms upon which we can build, the dream of artificial intelligence? Or if it isn't the platform, then what is the missing ingredient? Where do we go from here? How do we build on this to create AI systems? So the panelists are all the speakers that you've seen today, but I'm also very pleased to welcome Laura Gilbert. Laura is a chief data scientist at number 10 Downing Street, so he's going to bring a very, very different perspective to the discussions. Did I get the title right? Yes, okay. Okay, so I'm going to open the floor.
Start from there.
I beg your pardon?
Maybe start from this end.
I'm going to open the floor. Thank you, Mirella. Mirella has to leave to get a train back to Edinburgh, so if she runs, it's not running in disgust or anything like that.
Yes, I have to go for a pass. Yes.
It's the need to get home. So, who wants to go first? Tony, do you want to kick off? Let's start with question number 1.
So that was, do you believe foundation models, including ChatGPT, deserve the hype they've received?
Right.
Yes and no. I mean, it's certainly the most impressive thing I think I've seen during my, as referred to earlier, many years in AI. There hasn't been a bigger step change. I've seen many things, expert systems, Bayesian nets, all other kinds of things over the years. And it's the thing that's most impressed me over the years. I mean, it's kind of answering question 3, I guess. But I wasn't expecting that kind of level of performance already. So yes, they do deserve the hype because I think they're very impressive. But at least they deserve a certain level of hype. My worry is that they're being overhyped, as I think I already mentioned. Yes, they're great. I'm incredibly impressed, but I think that they don't. As we've seen the evaluation mechanisms and the various speeches already today, there are clearly things where they get things wrong. They're not perfect, and although they do some things well. I think there's certainly a danger of some people overhyping, and there's a danger in overhyping that there's then going to be an AI winter, because people won't believe the claims of AI people. Though if it's often not AI people, it's often the venture capitalists, it's the media. The biggest danger, I think Alan Bundy said this years ago, the biggest danger about AI in the public is that people are you need to educate them in how little AI can do as opposed to how much it can do.
Katie?
Yes, I was going to say, I do think that they deserve some level of hype. I think these systems are incredibly impressive and getting more impressive day by day. But I do worry about people, say even my age, other students, who then see these systems being fantastic and then start to use them in negative ways or in ways that they don't understand the limitations yet. And I don't think that there's enough infrastructure yet from the governmental side, academic industry side, to be able to sufficiently kind of curtail what these systems might be able to do in a negative way yet. So while I think that they deserve awe and smiles and laughter, and I think that they also deserve some degree of worry and infrastructure around that first.
Okay.
I agree entirely. I think, if we take hype to mean excitement, you've got a system that completely nails anything you're trying to do for a user. It's usable. It's effective at doing the thing you want it to do, and it's really interesting. So, yes, let's be really excited about it. If we look at the way we interact with the world as people, it's pretty much based on vision and language. So in between these two types of models, you're really covering quite a lot of how we interact with the world in one tech solution. So whilst there are obviously big downsides and lots of kind of areas to be very careful of, in terms of hype and excitement, yeah, I'm really excited, so I'm voting yes.
Okay. So Phil, you mentioned, you were very clear, this is the end point of a long program of research. Have we seen step changes, do you think, Phil?
Well, it's the current endpoint. It's not
right.
There's a lot more to be done. As an NLP researcher, the hype is absolutely there. So in my time in NLP, before the last few years, there's things that students spent whole PhDs on that these models do as an afterthought. Now, not even with the intention of solving that problem. Things in information extraction, all these sorts of things. It just comes out of the model. So from someone that's been involved in that and just things we didn't think that we thought were a long way from being able to do in that way, there's just been astonishing progress. From, say, a general public point of view, who come at this from much more of an anthropomorphic point of view, it's a lot more problematic, the hype. So these models do not understand language in a human-like way. They might look like they do, but they don't. And so you don't want to interpret them that way. So they're amazing tools, and they're going to have a huge impact. They're going to have a huge impact on the economies of some of the biggest companies in the world. But that doesn't mean we've solved AI or language understanding. A bit like we've been doing great things like machine translation without solving language understanding in that same way.
Yarin.
So, first of all, just a quick comment, because I think you would get different answers for people coming from different fields, and we have people from NLP, from AI. I'm neither of these. I'm a machine learning researcher as far as I'm concerned. And from my perspective, you could have asked the same question 8 years ago about reinforcement learning. And there's a lot of hype. The hype dies out, and then we have some useful tools after that. So I think we're going to get pretty useful tools, and we're going to get new technologies out of that. But beyond that, you can look at many parallels that we've had in the field over the past 5, 10, 20, 50 years.
Maria?
So I think someone needs to look at why we have the hype, right? So obviously the NLP, as Phil said, is the fluency of these models is amazing. The reasoning isn't, and I guess because they are so fluent, and they learn linguistic structure and the right combination of words and the right context. This makes them very human-like. So in that way, sort of that this has been achieved is amazing, and also certain tasks have come very close to being solved, but that's not completely the case. And so I think as an NLP researcher, the hype is about having these amazing tools that we can further build on for further reasoning and sort of a kind of explaining also where this kind of information comes when these summaries and content is being generated. But I think sort of we should not kind of lead to complacency in terms of, oh yes, this is great, it can do everything, and I think this is a danger coming from having kind of released the tool openly and people can do, yes, they can sort of crash test it, but also you can have other kind of strange implications, like students using them for their homework, and what happens after that? Are they going to sort of lose the capacity to write on their own, and with something also that's not completely there as a model? Is this going to affect human critical thinking? So yeah, I'm very excited from the point of view of how we can use these tools as NLP researchers, less excited about other things.
Okay, great. There was a soundbite in there that I don't know whether you credited it to Phil or whether it was yours. The fluency is amazing, the reasoning isn't. That's a really, really, really nice. Was that you, Phil, or was that was that yours, Maria?
That was
well, it's great. Definitely, I think that's worth writing down and remembering. That's a very nice way of putting it, I think. Mirella.
Quickly, I think the hype is worth it. What's happening right now is that we use language as a medium for everything. And this is going to be the future. And so as somebody who is working on NLP, this is great news. You use language to tell the computer to execute a program because language models will do the translation. You use these models to produce data that we use annotators for. And so language is the medium of everything, to generate pictures. And this is fascinating, and it's very different from reinforcement learning, I think, because it was never public-facing. Now, every grandmother knows ChatGPT. I'm not kidding. I mean, my son's friend, he has a grandmother, and she said to me, "Oh, you do this ChatGPT." She couldn't pronounce it, and I said, "Yes, ChatGPT." So she does know. So yeah, there is problems. We'll fix them. There is something left to be done. Stop here.
Percy, over to you. Did you want to come in at all?
Sure, I can make a quick comment. I think in terms of hype, the magnitude is right, but I think the direction is wrong. So like Phil, I think that from an academic perspective, this has been completely game-changing, a paradigm shift in the way that we think about NLP and AI systems. But if you look at the media, what happens is that a lot of the hype is focused on the anecdotal, the things that are really good. Look at this amazing web app I built in like 1 hour by just prompting versus look at all these insane things that Sydney is saying. And I feel like these are not necessarily the most productive things. I think there needs to be more focus on, what is this technology doing to our, society? Is this what we want? What happens to kind of the power dynamics of centralizations, whose values are being represented, who controls these things? And there's a long list of questions which are less tweetable, which I think should get attention. So I think of the hype as an opportunity to direct attention to the public's attention and raise awareness of some of these issues. But I think we have to capture that momentum and turn it to productive use.
Okay, great. So next question, and let's try and keep this one brief. Right? We want to try and keep some time for questions for the audience, for the panel. So just very briefly, bullet point answers. What capabilities of this class of systems, ChatGPT, GPT-3 and so on, most surprised you, if any? Which are the ones that really made you sort of sit back in your seat and say, wow, that's something different? I mean, certainly, as I said earlier, in my case, and I think for a lot of AI researchers who were used to trying to calm people down whenever they got excited about AI, we had to recalibrate a little bit, I think was my feeling, certainly when we saw GPT-3 come out, and we were all on our own in our homes in 2020 watching these developments unfold. So bullet point answers, very briefly. Tony.
We've already mentioned fluency. I think that was one of the most impressive things. But also, just to take one thing then, that when you ask it to do in the style of, there's a lovely example by Henry Minsky, son of Marvin. He was asked it to write as in the style of the American Constitution about losing odd socks in the washing machine. Look it up, it's brilliant.
I've been particularly impressed by what Percy called adaptation and just being able to give a few prompts or a few examples and get the system to kind of instantly go into whatever task you're trying to solve and understand instructions in that way.
I've got three things that I think have most impressed me out of quite a lot. The ability to write computer code, I didn't really see it coming. And particularly it's been useful already in front-end web development, which has really sped things up for some teams in government very, very quickly. The second one, I think, probably its ability to do quite well in the sort of theory of mind tests. So, you have claimed that they sort of pass at the level of a 9-year-old child. That probably, we would expect it coming, but I think it's faster than I thought. And then the third thing, and this has come up a few times today, is the sheer confidence and fluency with which it tells absolute untruths. I've met people like that. It's quite disconcerting, so that, yeah.
Number 10.
I guess I have an advantage because a couple of years ago when Lambda was being developed, I was actually at Google, so I had a sort of inside view of that model. And at the time, it amazed me for basically just the ability to hold a conversation. Up to that point, it's surprisingly hard to build a model that can actually respond in a sensible conversational way to anything you say. And these models just could always, there's sort of prior distribution over what a good conversation is. Was really amazing. The other thing that I saw at that time in that model is back then, and that was 2 years ago, they were integrating search into that model, and it can give an amazing search experience. The ability to not just search for something, but cross domains, to cross from your interests in music to holiday recommendations and things like that just gives a sort of experience that hasn't been available in search before, and is only now sort of coming out in products.
When those models were released, I remember being a bit skeptical about all those like prompt engineering approaches to try to get those things to do things well. One of my students had an interesting comment saying it's just a new interface to machine learning models. So this is actually tying to what you mentioned earlier, which is if you look at these as like language interfaces to machine learning, then I think that's a really interesting emergent property that I wouldn't have expected to come about.
I mean, for me, yes, the fluency is really surprising, and the fact that they can generate a poem that, yeah, I would have not been able to generate. And there was another example that I read of online of actually someone creating a fake language with ChatGPT, and then ChatGPT being consistent in the way of using that new language. And this was through interacting with it. I mean, this is sort of amazing. What it's learned about the structure of language is pretty amazing.
Mirella?
I think not so much GPT-3, but ChatGPT, there's two things that I think are impressive. And again, we don't know how they trained the model. I mean, we can have ideas, but we don't know the specifics. It generates fairly long documents. It can generate essays, and it's very chatty. And these documents are coherent. It used to be in NLP that there is a problem to generate such long text because there is coreference and anaphora, and it sounds broken. Now these are fluent. I don't know how they do it because they're like quite long. There is that. And the other one, which I think is an engineering feat they have accomplished, it is very fast. Inference with these models is like by seconds. I don't know what Microsoft are doing. I don't know what supercomputers they're using, but you don't wait. I don't know how they've done this because inference is costly. It's costly. It takes time. So that's that.
Percy.
I would say definitely the emergence of different capabilities, starting with GPT-3. The fact that you train a model to do this mindless thing called predict the next word, and all of a sudden you can prompt and do in-context learning and chain of thought and all that stuff is just crazy, right? I think the fact that you didn't even try to do any of these in some sense, and which means that there are probably more capabilities that are lurking, either in these models or in GPT-4 that we might not foresee. And that's the most exciting part, and from a scientific perspective.
Okay, great. I'm going to use my chair's privilege to say what I think is the thing that surprised me and excited the most was the thing I mentioned earlier, the idea that potentially you have a system which can't solve a problem directly, but can write a program to solve a problem, and that program itself can call ChatGPT or GPT-3. And as a computer scientist, I just find that just mind-expanding and beautiful. And I just think about Alan Turing in heaven doing a little dance at the idea that machines that pass the Turing test have that kind of capability. I think it's absolutely beautiful. And if I was a PhD student right now, I would ignore everybody's advice and I would just be spending all my time looking at that. I think it's just absolutely fascinating. Are we ahead or behind? I mean, I guess this is particularly for those in NLP in particular, but are we where you expected us to be? But quick reactions from the panel.
I mean, I've been tracking the sort of DL stuff in computer vision quite well, and that was generally proceeding pretty well, and that was quite impressive. And maybe I just missed it because I don't go to NLP conferences. I was really surprised that NLP kind of caught up where computer vision was. So for me, ahead.
I don't think I have the longitudinal enough view relative to answer this kind of question, but I am very surprised by how quickly, just since December, kind of to the first question, hype has taken off with ChatGPT. So I think that's impressive, but certainly faster than I would have even expected just a couple months ago.
It definitely depends on where your starting point is. I'm very optimistic. I would hope to be at this point, I think. But then I also hoped we'd have a warp drive by now, so I'm not sure my opinion counts.
Yeah, I'd equally say it's relative to what your sort of starting point is. I'd say let's go back maybe 4 years. I'd say way ahead of where I thought we'd be. If we went back 2 years, I'd say behind. And we're actually at an interesting point where the developments on more of the research side have been sort of stacking up and have been slower to come to market. I mean, ChatGPT is an example where having the opportunity to compare the Google Lambda system from 2 years ago conversationally is a stronger system and has more capabilities, but it was never released. And that, and a few years later, it's caught up, possibly because there was a flow of people from one company to another. But there's a lot of other things going on, and we're seeing the things like search and retrieval. Again, that's an idea from a few years ago that's slowly catching up. There's a bunch of others, the coding and action and things like this. So in some sense, we've sort of slowed down, and I think we'll go in those waves of speeding up and slowing down.
I very much agree with that, and also with the analogy to computer vision. I think what we're going to see in the next few years is these new results trickling down to downstream applications, and lots of applications that we couldn't have done before, like computer vision going down to downstream users, which is medical imaging, and then allowing them to do things they couldn't have done before. On the fundamental research side of things, of getting those models to be even better, it's a question to the NLP
I think we're
researchers.
behind, actually.
Yeah?
On the fundamental research front, I'm skipping your, I just want to talk again, but I do think we have slowed down. There is, the big thing now is instruction tuning. One idea, there is no 500 ones. And so I'm actually not very hopeful about what will happen at universities, because there is a huge generation of, this current generation of students who think that prompt tuning can give them a PhD. And I don't think, nobody's doing prompt tuning now, or even prompting, they're doing instruction tuning, but it is problematic. Maria, sorry.
Yeah. I would agree that there's sort of things that I think we're ahead of from where I thought we would be. So for example, we did a paper that was just published in journal on summarization of microblogs, and sort of at the moment, what you get out of the box is sort of nearly as good as what we did then. So it's kind of, suddenly what you produce as new work is very quickly becoming nearly obsolete. So yeah, I think in that respect we're moving very, very fast. But I guess in other respects, yes, I think there's kind of a slowing down from the homogenization that Mirella described in terms of kind of the different ideas that we're working on. But there are actually, I guess it's the homogenization on what becomes mainstream. Whereas I think there are still, kind of lots of different ideas around, how we improve and evaluate these models, but maybe these are not so mainstream.
Percy, did you want to come in?
Yeah, just really quickly. I think we're really ahead on capabilities, but we're far behind on safety understanding. So that's a problem.
Yeah. I think probably everybody on the panel would agree with that with that point. Is it going to flatline? Are we going to run out of data or compute, or are we going to run out of scientific innovations? I mean, we did see this in the 80s. There was a huge flurry of activity, and it was, I think it was data and compute that just that led to that. The ideas, the core ideas, seem to be there. Are we going to see the same thing again?
Somewhere in between, I think. I don't think it's going to flatline. I think we've sort of seen the sharpest, steepest part of the curve, but I think in terms of data, I do worry that they seem to have used everything already, haven't they? And there's a worry about the fact that the web is now contaminated with bot-produced text, and that's going to then may have a negative effect on future training. So I worry about that. But I still think there's definitely more opportunity for future technologies and better prompt engineering and all these other kinds. Also, I think multimodal. I think that's still a big unexplored area. So I sort of see. But if we went here and we're not doing flatlining, but we're somewhere between.
I think there's a big jump that we can get by further exploring the human-machine interaction side, kind of like what Percy was saying with interactivity, as well as we've already seen with reinforcement learning with human feedback, getting different kinds of input and information from people, studying how human users are going to actually interact with these systems across domains. I think that's where we can see another big jump. And I think people are so complicated, and there's so many things that people might do with these systems and do with these systems as they get better, that I think that there's a lot of room for continual growth there.
I think I entirely agree with that. There's such a lot of interest, and there are almost infinite use cases. So the drive forward, it's difficult to see what would stop that in the near future. And if you then start combining the different types of AI to solve, bigger sort of cross-disciplinary problems, I think there's a lot of future potential still to go.
Research always moves in sort of flat periods and then periods of quick advances. So we can expect that to continue. Now is very different to the 80s and 90s of neural networks. And if you look at language modeling up until very recently was almost entirely funded by US defense and intelligence and the EU. Now it has real commercial value. And so it's a very different world in terms of funding. In terms of advances, there's a lot of focus on these large scrapes of data for training the base language models. That's not really where the sort of battle is now. The battle is in user data. That's what's really driving advantage. That's the difference between ChatGPT and other base models. It's not the better base trained model, it's better user data, better annotation data, and that's a very different business. You have to have users, you have to have a lot of money to spend on annotation, and that creates moats between companies that others don't catch up. But that's where a lot of the action now, and where we'll see steep developments, at least in the sort of coming year or two.
So I think we will, but at the same time, in order to have an exponential increase in development, we need to have more than just a few players working on research on those topics. And at the moment, it's basically impossible for anyone outside of these big tech companies to do that.
Well, in fact, we have to pay them to be able to use ChatGPT and stuff, which is
research that I showed earlier today. You need to think very creatively. How do you pose a research question that you can answer just using API access? And still not being able to probe lots of other things that we want to understand about how these things work. And that's a big bottleneck that unless we manage to find some way of working on those research questions, we will not see as much progress as otherwise.
I definitely think that there will be researcher needs driving this area. So for kind of models that are better for different kinds of users and can do better reasoning and can explain better, their decisions or sort of evidence and so on. And of course, I agree with the problem of who are the people going to do this work? Can we as academics work with these models as effectively, or are we still going to be working with sort of smaller models? And will what we do be as relevant? So hopefully it will be.
So I think it's not so pessimistic. So I think we will see a trend towards smaller models, more specialized ones. That's what they're doing. There used to be the case that you will have this language model that would do everything. I think people think this is not the case anymore. So they start fine-tuning them. They start specializing them with these instructions, with the human users, whatnot. So there will be research there. And there is another big area which they are not considering, or maybe they are, multilinguality. So all these models are in English. They've seen all over the English web. There is languages where you don't have such a huge web presence. We will need models to deal with multiple languages if we want NLP to be democratized and, reach all the corners of the world. So I'm quite excited about the multilingual work ahead. And yeah, we'll see.
Percy.
I think we're going to continue seeing the commercialization and industrialization of these technologies. I think that's the major thing that will happen in the next few years, given the amount of funding and interest and clear kind of economic value that's generated. And so that's going to be a pretty big change, I think, to society. It almost kind of makes me think of kind of this, semiconductor industry, or maybe, when information retrieval went from kind of being a more academic enterprise into kind of modern commercial search engines. And I think this was going to expose a lot of interesting, studying the social impact, I think, of what this technology is doing is probably one of the most interesting and important areas of research. Now, for the more scientific, kind of quote unquote pure scientific understanding or new techniques, there's definitely going to be a new paradigm in 10 years or so. There always is. If you look historically, from symbolic AI to machine learning to deep learning to here, it's not that we're going to throw everything out the window, right? And we're still doing machine learning, we're still doing deep learning, but the abstractions that a researcher has and what kind of framing and problems and how they conceptualize what these techniques are doing and not doing, I think is going to change. I can't predict what it will exactly be, but it just has to be the case.
Okay, thanks. I guess from my perspective, I think there's 2 points to make. I think the first is the shake-up that we've seen in the AI industry, which has been incredibly active, ludicrously active over the past decade, but particularly the prompt that's been given by ChatGPT going viral and the firework that's put under the seats of a lot of big tech companies has created a huge amount of momentum. And within a year, we will start to see that, I think, bear fruit. We will start to see other companies racing to catch up to get products to market. That's another great big conversation that we could have about the speed with which that happens. It's got a lot of press, but I think we will see a flurry of interest. But actually, even if there was no advance in the core technologies at all, if we just froze the base technologies at the level of GPT-3 and ChatGPT and the tools that Phil and others were talking about, I think we would have a decade of incredible innovation just building on top of those, just exploring what they can do, finding what they can do, using them in creative ways. So I think we've already got an amazing starting point to start building on, I think. Okay, next question. What's the killer app? What's the thing that's really going to take off? And here I think I'm going to use the analogy of mobile phones. When mobile phones first started to become big at the end of the 1990s and they became affordable and everybody started to get them, everybody was startled to see teenagers spent their entire lives texting each other. And texting turned into basically social media, right? That's why Twitter used to have the 140 character or whatever it is limit. And by and large, people didn't see that coming, that was going to be a killer app for mobile phones. So in exactly the same way, you've got a bunch of somewhat elderly people on the stage in front of you with a range of ages, Yarin. Yarin and Katie.
Shall we all storm off?
We are digital immigrants and we did not grow up with this technology, with digital technology, and our kids use it in ways that we'd never predict and never imagine. And it is an extremely safe bet that exactly the same thing will happen to this technology, that the people that grow up with it will just naturally use it in ways that we don't anticipate. But let's nevertheless speculate, and in our dotage we can come back on our speculation and laugh at how wrong we were. Killer apps, what do we think it will be, Tony?
It's always hard to predict, especially in the future.
Yes.
I mean, it depends partly as to whether we're talking about short-term or longer-term. I think short-term, killer apps are all going to have to be human in the loop. So because there's enough unreliability, enough lack of robustness. So there's companies already using ChatGPT to draft emails for customer service reps, and then they get edited by the human, but it saves a lot of time. So that kind of thing, I think, is here now already, and there's going to be more things like that. What are my kids going to be doing, or your kids going to be doing in 5 years' time? I'm not sure. It's hard to see these things coming. I think I'm going to pass on what the real killer app is.
I think my sense for people that are my age of first-year PhD students or in high school, college, I think for education will be a big area that students will increasingly turn to ChatGPT or similar technologies to try to summarize some topic that they're trying to learn, maybe propose new problems, I think is something that I've seen people doing. So I think in that realm is where you could get a lot more applications. But to your example of social media, I do worry that the next generation of younger folks will increasingly turn to these systems as kind of a crutch, like Maria was starting to mention, whether there will be the same level of critical thinking. So I think the killer application also has some serious concerns, which we could discuss more in the next question.
So probably not exactly in the realms of a killer application, but sort of the future of how I'd really love to see this go, and this is a very much personal view. You could use this kind of technology in the round to really level people up. You won't need as money to have a lawyer anymore. There are so many fields in which things that people currently can't access due to funds, experience, background, you could really open up and make accessible to people. And sort of along the similar veins, the future of work it will hopefully change entirely. And it's everything from people doing really mundane tasks that could be doing something more interesting, through to sort of healthcare, where we see healthcare workers that desperately want to look after people and actually spend a lot of their time doing paperwork. And that paperwork, when done when you're very tired and stressed and have been doing lots of repetitive work, can be dangerous. Mistakes on paperwork in healthcare kill people. But other than just sort of automating systems more, when we sort of look at data and evidence about the ways that people work, it has obviously a very strong positive and negative impact on people's well-being. And there are a lot of studies that sort of suggest that your 5-day working week, particularly for people doing repetitive tasks, it's bad for people as humans. We could have a world where the work we do is more interesting and potentially you spend less of your time doing it across the board with sort of the same amounts of money available. So we could have a more equal society, and a society where work and engagement with work is more rewarding and there's more time for family and things like that. So that's my dream.
Okay, possibly less uplifting, but I mean, the obvious short-term ones are search. It's clearly a killer application for this sort of thing. Then there's what I'd call action, which I had this sort of hierarchy on a slide, and retrieval at the top. I sometimes put action above that, which is a bit what Mark is referring to in terms of being able to execute programs. Basically, when these models can interact with the world and not just output text. And that can involve a lot of things, from sort of embodied robotics of science fiction, but also killer apps like visualization. So not just have a discussion with a model, but have it create graphs, visualizations, other things as part of that. Then also, if you look at chatbots, there's a lot of chatbots that have existed before ChatGPT. The models you're seeing that currently have been designed they've attempted to make them impartial, information-seeking agents. There are lots of other sorts of agents that we could see that are not necessarily impartial, play roles of characters. We also already see a lot of that in the chatbot world, if you've come across Replica and these other services. And I think we're going to see a proliferation of characters from these sorts of models, and that will have and people will find really interesting applications for these.
Going back to your texting example, that you need to grow up with the technology to understand how to use it as like a native, digital citizen. I think coding is one of those things that everyone growing up now will do coding using these autocomplete much like really proper advanced autocomplete that you wouldn't have been, like, you would change completely how you do coding, how you do software engineering, and that's, I think, one big application. I know that graphics, people use generative art to basically to iterate over ideas and basically changing the way that we do graphic design, for example, and coming up with brainstorming ideas. The pedagogical side, we're basically being forced to change how we evaluate students' exams, because if a student can automatically write an essay, then we need to think of how do we evaluate student performance differently, making the evaluations more analytical rather than just textbook questions. And the last thing, which I really hope will not happen, is automating HR. Which I'm sure someone in the audience is already thinking about that, and that's going to be like my worst nightmare is these automatic phone systems where you call and like it tries to direct you to the correct person to talk to, and that's going to be using ChatGPT and we get into an argument with you over the phone about who you need to talk to and why you shouldn't talk to the person you want to talk to.
I think that what will be sort of really important technology further down the line will be personalized interaction with multimodal and heterogeneous information. And so I think this is sort of partly covered by what Phil said, but I can see this having huge applications, for example, in personalized healthcare, and sort of you're kind of identifying a lot about sort of, looking at, I'm a health freak, so for me this is really a killer app, and kind of working in this space is how you kind of synthesize all these kinds of different information about you, your history from kind of the logs you make about yourself, but also kind of different medical records or other records, and you're kind of bringing this and sort of understanding better things about how you're doing. And but I think generally this kind of personalized interaction with kind of very heterogeneous kinds of information.
So I don't know whether I have two applications in mind, but I do not know that there will be killer apps. One, which I think would be a shame not to be the case, would be AI in education, and by that I don't mean helping students to cheat in exams. I mean having high school or primary school pupils that are being helped by an AI system that helps them revise, or it summarizes material, asks them questions, and helps them learn. And this is highly personalized. And if I were to do a startup, that would be my startup, AI in education. And another one is the use of these models in creative industries, like give me an idea for a screenplay, give me an idea for a story, let's write it together, let's do it together, but creatively, not like rehashing ideas that it has seen before. Yeah.
Percy, did you want to come in?
Yeah, I would say advancing science, scientific discovery, drug discovery materials, even AI research itself, having models that can read the literature, form hypotheses, run experiments, take data, perform analysis, and basically replace my job in a way. But generally create and advance scientific knowledge. That feels like really exciting, and in a kind of a deep way. Whereas I think a lot of people think these models, I think by now people think that they're sort of creative, but there's always a sense like, oh, you're just looking at the training data, but showing that these models can actually advance the kind of the frontier of what we as a humanity knows, I think is incredibly exciting.
Okay, so we talked about the ups, let's talk about the downs. We've seen quite a lot of concerns expressed throughout the day, and obviously, particularly over the last week, there's been a lot of press around tools that have been released or pre-released getting things wrong. What are our top concerns and why? Very briefly, because we do want to leave a few minutes for the audience to ask questions. Top concerns and why?
I already talked about quite a lot of these in my talk earlier: robustness, brittleness, explanation, proper explanation. There's been criticism of these LLMs as being stochastic parrots. I think that's a bit harsh, but I think there is a worry that they're not really, it's statistical, predicting next word, next sentence, and there's a lack of understanding. And there's the other side of the coin is when they do well, humans then tend to overtrust them. We've seen this in self-driving cars. The car manufacturer says you must remain in control of your car all the time. It's driving fine down the highway, so people go and make coffee, they watch a film, they turn around and help the kids in the back, and then there's a crash.
Yes, I have two. Of one, misplaced reliance, which is something I've talked a lot about with Umang Bhatt and Adrian Weller and Valerie Chen, of people either over-relying on the systems when they shouldn't, or under-relying on the systems when they actually probably should be relying on the systems because they might have lost trust. And the second is actually the environmental impact of training these systems and keeping them running at scale. Again, someone was mentioning that we don't know how many supercomputers Microsoft is necessarily using to host Sydney or host ChatGPT, and I do worry about that a little bit, a good amount.
Environmental impact's a good one. I think I think everyone's worrying about a lot of the same things. For me, it's definitely the sort of hostile use against individuals. And I had a conversation with somebody at work recently, and I said, I'm quite worried that we won't know when to trust them and when not. And they said, oh, well, our children will grow up, with AI systems, and they'll know how to use them. I grew up with advertising, and I still see an advert from L'Oreal saying this will make you look, thank you very much, 20 years younger. And I want to believe it. Humans are very credulous. It's part of being a social species. If people tell you something, generally we believe it's true. I saw a great argument for this. Somebody runs into your cave and goes, quick, quick, run, there's a fleet of saber-toothed tigers on the way. The guy that goes, I think I'll just check, is the one that gets eaten. So, there's this very strong inbuilt desire to believe things that we read that, don't invoke any particular cognitive dissonance, which means that we're very, very susceptible if people then want to use that against us. And when you look now on Twitter at chatbots trying to influence people to do things, and the very wide range of radicalization activities there are, and I'm not talking terrorism particularly, flat earth, anti-vaccine, this sort of thing, you'd be able to do that really, really well now. And I don't think we've got a good grip on how to protect ourselves against that kind of influence. So I think that's my key concern, is how do we teach people to be safe?
I'd share all the concerns mentioned. I mean, to give a specific sort of commercial deployment point of view, one of the things that concerns me, which is in terms of safety, which is different from the sort of academic focus in the field, is controllability, because we see all sorts of very contradictory requirements from people using the models in terms of what they output, whether they want to use a model in a sense that they never want to see something offensive, or they want to specifically use a model in a case to deal with offensive content. You get very different requirements, whether you want the model to take a certain opinion or have no opinion. All of these, there's all these sort of policy decisions around exactly in which different circumstances we want the models to behave in certain ways. At the moment, we don't have good ways to control that. So we don't have a good way to guarantee that, okay, we do this and then it's going to behave in that way. So less so much of just being able to sort of completely sort of filter a model or say it's not going to do X. It's more saying in this circumstance it will behave in this way, and in this circumstance I can have it behave in this way.
So beyond all the concerns mentioned, I think another one is also people using those tools in the applications without understanding the limitations, without understanding that these models can hallucinate answers when they don't have enough information, or they don't know what the answer should be. I had something else in mind, but I forgot, so let's continue. I might remember that.
Yeah, I think human complacency in using these tools is what I'm concerned about, both in terms of over-reliance, but also in terms of, I guess, generally losing critical thinking. And so, I mean, a big part of my education was sort of writing my thoughts. You write a paper, you write an essay, and that helps you articulate, and it helps you think. So I'm kind of wondering whether, if we have these great authoring tools, will, the new generations rely too much on them and is that going to impact kind of the ways they kind of think? So I guess I mean, hopefully we'll just adapt, and they'll make us even better and more creative. But this is a concern I have.
Okay, Percy.
Yeah, just two things. To follow up on that, I think I share the worry that there's just going to be a loss of agency once these models can predict what you should be doing better than you. I think there's going to be a lack of incentive to really think in some ways. The second thing I think is more structural, and I alluded to this earlier, is centralization of power. I think these foundation models are extremely important. I think of them as really societal infrastructure. And when you have something as important as that, I think having a certain amount of openness and transparency is important. We've seen this, how it's been useful, for example, for the internet, email, Wikipedia, these things which are in the commons, which are sort of collectives and managed. And right now, I think we're on a course to having, maybe a duopoly, or very few actors having the most dominant models, where there's really a lot of opaqueness into how these models are built, what do they do. They're aligned to values, but whose values and what should we be expecting from them? And I think that is kind of a dangerous world and not a stable world to live in.
Okay, great. So last question, and again briefly, because we really want to try and give at least a couple of questions from the audience. Where do we go from here? What do we do next? What do we, if we're going to fund a program of AI research, what would we aim? What do we think are the missing ingredients? What should we add? What should we be aiming to add? I know what you're going to say, Tony. Go on.
Symbolic reasoning. I mean, it's a very, as I mentioned earlier, it's clearly a very active part of the research at the moment, is neurosymbolic. I mean, the first part of your question is, are foundations indeed the right foundation for AI? And I was going to say, no, not the foundation. They are part of the foundation, or they are a foundation. I mean, we need that, and we need RL, and we need symbolic stuff, and we need probabilistic, explicit probabilistic. There's lots of things we need, and it's one more tool in our arsenal. And I'm sure that LLMs are going to be part of, and foundation models are going to be part of, any future AI we're going to build. More integration between these different kind of components, and I think that there's all to play for.
I think human-machine teams and really studying human interaction in these systems, and also coupling with Yarin's talking, we were just saying about probabilistic. I think uncertainty, not just machine uncertainty and getting calibrated machine uncertainty, but also studying human uncertainty and how human uncertainty changes as people interact with these systems. I think that's really exciting as a future direction.
I am not the world's leading expert in here, and I'm sat with a lot of academics who know a lot more about this than I do, so I'm just going to pass on here.
So, as has been sort of made repeatedly clear, these models do not understand language in a way a human does. They've not solved the problem of AI in any sense, or language understanding. So there's a huge amount of work still to be done in understanding how do we make progress on those problems. Traditionally, AI has focused a great deal on the representation problem. These models entirely sidestep that problem in a sense, but there's still a lot to be done on understanding sort of how do we get the sort of, and data efficiency is a good way to see this, the sort of data efficiency that humans have, the ability to induce structures that these models don't induce. So there's a lot of work to be done there, and huge opportunities for AI researchers. There's also huge opportunities now in systems research. So how do you make these models more efficient, more scalable, to use less energy? There's just a really interesting space there. I think in my talk, I showed a sort of crazy graph of what goes wrong when these models don't work out, solving a lot of those problems, which are really sort of low-level, complicated problems, interactions in big accelerators. There's a huge amount of work there that there's a big potential to really increase the efficiency of just what we have now beyond changing the models.
I think one of the topics that actually was discussed a lot during the day was metrics, benchmarks, and evaluations for progress in the field, and codifying how do we measure progress given these fuzzy generations that look very fluent but are difficult to understand whether they actually do what we want them to do. That, together with trying more to democratize some of those tools to allow us to dig into what's going on inside them without having to be tied to corporate interests of we don't want negative PR, therefore we don't want you to publish about biases in those models, I think is one of the cornerstones for us to be able to answer some of the big questions.
Yeah, so I think definitely evaluation of capabilities and then incorporation of reasoning, better inference ability. So I guess combination with sort of neurosymbolic, probabilistic, so this kind of area.
Percy?
I want to second Yarin's comment and on measurement. I think we are so behind in terms of measuring what the capabilities of these models are. Like the NLP community, we still have like our conventional QA, summarization, named entity recognition tasks. But if you see the stuff that this model can do, it's way beyond that. And all we have is right now kind of anecdotal evidence of like, oh, here's some examples of what it can and can't do. I think we need a much more rigorous discipline for measuring these things. I think one challenge is that it's getting to the point where even human evaluation is not enough. It used to be the case that methods were sort of like not good enough, where you put in front of a quote unquote average human and they can just tell you what's wrong. But the errors that you get are so subtle now, and they require a lot of domain expertise. Often I use these models and I see, oh, it looks reasonable, and then I ask the question that I have much deeper expertise, like on foundation models, and I see that these answers are just not good. They're just off. They're not necessarily wrong, but there's misleading in subtle ways. And I think developing protocols for evaluating that kind of last 5% is going to be incredibly challenging. I think I would say transparency is probably the immediate most prerequisite for that. I think it's so early and things are moving fast that I wouldn't comfortable saying you need to pass a certain level of capability before launch, or you can't output this toxic content or that. I think it's really hard to say, but having a commitment to transparency and engaging in some sort of consortium to work out some of these issues, I think getting the process right is number one priority right now.
Anybody else want to come in on that?
I think, by analogy, if you buy sort of a device off the market, it has a specification and it has operating limits. It says you shouldn't use it below 5 degrees or above 40 degrees or whatever it is. And we've got all these AI systems now, and they're not advertised with when they should be used and what the limits are. And so you get very good performance, and then suddenly they drop off the edge, partly because they're not self-aware and they don't know what they don't know. And so, I mean, it's a very hard thing to legislate on, but something along those lines would be good.
Maria, did you want to come in?
Yeah, so transparency is very important. Also, I think sort of building avenues for collaboration with academics as well, because as we said, we don't have kind of necessarily the capacity that large companies do. So I think this is an important requirement.
I think one of the things that's come out of today, which was a belief that I had, which has just been confirmed by all of the speakers, that actually systematically evaluating the technology is terribly hard. And actually, it turns out that this is a research area in its own right. It's like some new substance has been beamed down to planet Earth, and we don't know what its chemical properties are or any of its other kind of properties, and we're all frantically trying to understand it. But actually, we don't really quite yet have the tools to be able to do that. We don't understand, it seems to me, to be able to do that in a systematic way. And that really seems to have been one of the big themes that I've picked up from today.
I'll add to that a huge complication, which is we literally have black boxes. Not black boxes because there's a neural network, deep learning, we don't understand what they're doing. Black boxes because all I have to do research is API access, and I don't know what's on the other side of the API. I don't know if using OpenAI API access, I don't know if they change the model from one day to another. I don't know if they're doing some pre-filtering, pre-processing, post-processing. I can't answer any, the questions that I can answer are with respect to capabilities of the API, not capabilities of the model. And unless I have access to the actual model itself, it's impossible for me to even answer those questions about what the model itself can do.
Anybody else?
Maybe I can jump in as well. I've thought a lot about this question. I think maybe to frame things, there's intrinsic evaluation, which is often simpler and more automatic, and HELM is an example of intrinsic motive evaluation. And there's extrinsic motive evaluation, which is not on the foundation model, but actually on the whole system and the user in sort of an ecologically valid setting. And I think you need both. One to chart progress and the other to see how well you're doing. Ideally, you would have both and sort of try to correlate the two so that you have surrogates that are much cheaper to evaluate and still give you signal, but ultimately you still need to once in a while do the actual in-field experiments, which is much more costly.
I think we've got a question at the back, and then we should probably be wrapping up, I'm afraid.
One of the things that we're trying to do is understand the underlying mechanisms that allow this really interesting emergent behavior with large language models, that allows us to do few shot learning, that allows us to do like in-context learning, and basically get models to adapt very quickly to new tasks, and then exploit that mechanism for other domains like structural biology, protein fitness prediction, and so on. So I think that's ongoing research, which I think one of the most interesting things to look into.
Anybody else want to come in?
And it's definitely something that you want to solve across the board. If you can find a system that addresses how systems work and engage, you've solved a lot of the problems that we need to solve. You know, anything that can identify how everything from traffic flows works in a really meaningful way, supply chains, what happens if I impact a system this way, through to environmental impacts of certain activities, that would be the holy grail, really.
I guess there's also work on incorporating tabular data in language models. So I guess this is sort of another area that you could look into if you're interested in. And I guess anything that can be vectorized can go into a large language model and enhance it.
Okay, any last comments? Okay, then folks, looking at the clock, we're going to have to, I realize there are many more questions. You will have the opportunity to talk to the speakers directly. So let me just say a few words to wrap up today. Firstly, thank you to all of the speakers for coming and speaking. Mirella had to run for her train. It's been a great day. I think it's greatly exceeded my expectations, which were high in any case. I think we've seen a number of very strong themes emerge. It's confirmed my personal belief that this is an important and exciting area. But I really appreciate the effort that you've all made when you're all ludicrously busy, because everybody in AI is ludicrously busy these days. I really appreciate it. Percy, special thank you to you for joining us. We realize it's early in the morning for you, so my belief is that now you're going to head down to the beach and go surfing or something like that in California. We really appreciate you taking the time to do that. It's been great to hear from you, and at some opportunity it would be great to see you face to face in the UK. Okay, next thanks, I want to thank the Turing team for helping organize this event. As I say, originally it was planned in October, and then we had to postpone it for all sorts of complicated reasons. It was planned for December, and then it was bang in the middle of a train strike period, and this has created an awful lot of work for the Turing team. So in particular, I want to thank Katie and Ruth. Where is Katie? Ruth is over there. Katie is hiding somewhere down here. You've both been wonderful and incredibly accommodating. And all the VIPs in the audience that got in touch with us over the last 48 hours and said, we realize you're sold out, but is there any way you could squeeze us in? You should be thanking Katie and Ruth for the efforts they've gone through. But I really appreciate it. So this is a Turing event. The Turing Institute is the UK's national centre for AI and data science. And we recognised within the AI programme at the Turing that this technology was going to be important. And we initiated a piece of work a year ago to start to actually around benchmarking that technology, which I say has emerged as one of the themes that we've seen today. This event is part of that. Your seats here are subsidised by the Turing. The nominal fee that we charge for attendance does not remotely cover the cost of your seat today. But we felt that was worth doing because we felt this was important for the UK, and we wanted to convene the UK's community in this area. We wanted to get everybody in the UK who's got an interest in and a passion for this emerging new technology in the room today. We have a program of work going forward on benchmarking, but our aspiration, as I mentioned earlier, is for a national level activity. The Turing took the lead in this space in the UK by initiating activity in this space. We think the nature of this technology is such that an activity would need to be led by a national level body, but would need to bring in other universities, research sectors, UK government stakeholders. I cannot tell you how many discussions we've had with UK government stakeholders about this technology, trying to advise them about how to use this technology safely and reliably. And actually, it's been incredibly reassuring to me to see that that's the number one concern of our civil servants. We would like to use this. We can see a million use cases for it, but we're not going to do that unless we can do that safely and reliably. And we will continue to work with them to understand what their needs are. We will continue to work with our university partners across the UK sector and our private sector stakeholders. I very much hope that we will see a UK national initiative in this area. And I noticed this morning there's an announcement in the press from a cross-party group recommending an investment in a sovereign AI capability, which is exactly the terminology that the Turing has been using. So exciting times. This has been a great day. As I say, it's exceeded my expectations. I really hope you've all enjoyed it. But it's not over. We now have a reception. And having mistakenly promised you coffee earlier when there was no coffee, I'm not going to make that mistake again. But what I can say with confidence is that in expectation, there will be cheap red wine and warm Prosecco. In expectation. So please join us in the reception and let's continue the conversation there. Thank you, everybody.